The Institute of Research on Combustion, IRC, was settled in Naples in 1968 thanks to the foresight of Leopoldo Massimilla. It belongs to the Department of Engineering, ICT and Energy and Transportation Technologies of the Italian National Research Council. At present, the institute involves 29 researchers, 24 technicians and administrative assistants, and several fellows. The current director of the Institute of Research on Combustion is Riccardo Cherone.
Let me give a brief introduction on our institute. The mission of the Institute of Research of Combustion is to develop a fundamental understanding and new technologies in the area of combustion power and energy systems by providing technological leadership with a vigorous program of research coupled with education and technological transfer to and from the marketplace.
The balance between fundamental and applied research is good, as well as the integration among groups. A large number of students coming from different places contribute to the research activity and guarantee the continuous flux of new ideas and energies.
The Institute has strong cooperative relationships with different university, research centers and companies in Italy and abroad. The Institute of Research on Combustion carries out research in areas of strategic importance for the national level of innovations, with the implication of several fields: energy, industry, safety, environment and new materials.
The main activities aim to develop combustion processes with low environmental impact, new technologies for electric and thermal energy production, thermovalorization of wastes, biomass and alternative fuels. The activity includes also the measurement of parameters relevant to industrial risk assessment, such as flammability and explosion limits.
The general scope is the progressive upgrade of already available combustion technologies in terms of environmental impact, as well as the development of innovative and alternative technologies able to optimize the energetic efficiency and to minimize the environmental impact of combustion in terms of emissions of pollutants and greenhouse gases.
The Institute fully accomplishes its mission, and it has developed over the years into one of the most prestigious centres of excellence on combustion, recognised worldwide, with a relevant production of papers in international journals and several patents. The activity of Institute of Research on Combustion is organised in the framework of 6 strategic projects: fossil fuels processes and technologies, clean energy and chemicals production, processes and technologies for renewable energy, processes and technologies for the valorization of wastes and biomasses, gaseous and aerosol pollutants, formation, diagnostics and abatement, advanced catalysts and materials for sustainable chemistry and energy, process safety and accidental combustion phenomena. The fossil fuels processes and technologies, clean energy and chemicals production project includes studies on the sustainable use of fossil fuels. Activities are performed to increase of the efficiency and sustainability of consolidated technologies. Novel concepts and new combustion processes as oxy-firing, chemical looping combustion, mild and catalytic combustion are studied. The activity also includes studies on CO2 capture, in particular calcium looping, biomimetic absorption and CO2 absorption on fine powders processes. The Processes and Technologies for Renewable Energy project deals with the development and integration of processes and technologies that uses renewable sources for a low cost and low carbon production of energy and materials. The exploitation of solar energy and the production and use of biofuels are the main tasks of this project. In this framework, studies are also directed to the development of cogeneration devices that integrate biomass and solar energies. The Processes and Technologies for the Valorization of Wastes and Biomasses project deals with the definition, development and integration of processes and technologies for the valorization of wastes and residual biomass. The goal is to provide a sustainable cycles with a focus on energetic issues. The activity is carried out combining multi-step and multifaceted processes, including pre-treatment, processing and reforming steps. The gaseous and aerosol pollutants formation, diagnostics and abatement project includes several tasks concerning characterization and control of combustion-formed species. The study of formation mechanism of regulated and unregulated pollutants produced by combustion sources is studied by advanced in situ and extra situ diagnostics. The monitoring of emissions from combustion and gasification sources is performed by conventional and unconventional measurement techniques. The study of possible actions focused to reduce pollutant emissions is also made. The Advanced Catalysts and Materials for Sustainable Chemistry and Energy project deals with activities aimed to the development of novel and advanced materials and catalysts. Activities are performed for process intensification and/or the development of new alternative processes by the development of innovative powder and structured catalytic systems and the synthesis of advanced carbon-based hybrids and inorganics materials. The Process Safety and Accidental Combustion Phenomena project deals with the development of experimental prototypes and protocols. Predictive mathematical models for analysis, prevention and mitigation of the industrial risk associated with explosions, fires and release of toxic substances are developed. Process safety, combustion safety and risk assessment are main tasks of this project. The Institute of Research on Combustion carries out large research programs using a rich, high-valued equipment and devices from the laboratory to the pilot scale, as well as high-performance computing. Studies and operative tests on conventional and innovative reactive processes can be performed on different types of available experimental facilities, such as fluidized bed combustors and gasifiers, catalytic combustors, high-pressure spray combustors, high-pressure stirred and tubular reactors, gas turbines, laminar flames reactors, domestic boilers and fireplaces using renewable fuels, bioreactors. Online and offline measurements techniques include UV visible and infrared spectroscopy, fluorescence spectroscopy, mass spectrometry, gas and liquid chromatography, X-ray diffraction and Raman spectroscopy, differential mobility particle and dynamic light scattering size analyzers and impactors for particulate characterization in aerosols. Other relevant diagnostics for chemical, physical and structural characterization are also available, including thermal analysis devices, atomic force microscopy and scanning electron microscopy, porosimetry, elemental analysis and differential scanning calorimetry. If you are interested in taking advantage of expertise and equipment of IRC, as well as to have joint research activities or highly specialized services, please do not hesitate to contact us.